A vessel about to complete loading in a summer zone is expected to enter a winter zone after steaming from loading port for 10 days. On passage, fuel consumption is expected to be 30 ton per day and water consumption 15 ton per day. The ship is at present floating in water of density 1.013 ton per meter cube at a draft of 9 meters. Summer load draft 9.475 meters. Freshwater allowance 203 millimeter. TBC 30 ton by 1 centimeter. It is for seawater basically. Find the maximum permissible draft on completion of loading. Find also the amount of cargo which the vessel can load. You have studied about load line marks earlier,
Yes, sir. Plimsoll line.
plimsoll line and everything. I hope you
Yes, sir.
remember the contents of the same. Yes.
Yeah, 300 millimeters and that statutory.
Yes. You got it right. Okay, fine. We will utilize those concepts here. Okay,
Sure, sir.
fine. So now you see the whole problem may seem to be a little confusing to us. So let us segregate it in several parts. Let us read it one by one. So a vessel about to complete loading in a summer zone is expected to enter a winter zone after steaming from the loading port for 10 days. As if the ship was earlier in summer zone, look at the diagram please, and it is now moving in winter zone. Okay, and it
Yes,
is
sir.
going to take in total 10 days to cover the voyage. It is going to take 10 days. Okay, on
Yes,
the
sir.
passage, the fuel consumption is expected to be 30 ton per day and water consumption 15 ton per day. And let us assume as if there are no further consumptions, okay, except these two. So fuel consumption per day is 30 ton, water consumption per day is 15 ton. How much is the total consumption?
300 ton and 150 ton. Oh, okay. Total consumption. Yes, yes.
30 ton plus 15. Okay, that means
45 ton. Yes,
45
sir.
ton. So this much is the total consumption in a day. And how many days we have been given?
10 days.
10 days. 10 days. So how much will be the total voyage consumption?
450 tons.
The consumption per day multiplied by number of days. That means 45 into 10. That means 450 ton. Clear?
Yes, sir. Yes, sir.
That means the ship's displacement will get reduced by this much amount. This is like on the voyage,
Removal of
450
weight.
ton has been
Removed.
removed from the ship. Okay. Yes, or has been consumed from the ship. Let us remember this.
Okay.
Okay. Now, you know,
Sure, sir.
increase in draft because of addition of mass, how it is determined?
Increase
Mass
in
upon
draft. Yes, sir.
mass upon TPC. Okay.
Yeah.
And similarly, decrease in draft or reduction in draft because of removal of mass will be determined by dividing mass with the TPC. Clear?
Yes, sir.
Yes. We are assuming as if the ship was initially in water of density 1.013 ton per meter cube, but on rest of the voyage, it will be floating in seawater. So that's why
Seattle.
we are taking into consideration the TPC for seawater here.
Yes, sir.
Clear? So
Yes, sir.
reduction in mean draft will be 450 divided by 30. 30 is the value of TPC given to us. Let me use this. Okay. So 15 centimeters. For your information,
Draft will
when we
be
divide the mass with the TPC, it gives us the change in mean draft in centimeters. Converting
centimeters.
in meters will give us 0.15 meters.
Okay, sir.
Understood? Okay.
Yes, sir.
Now taking you further. Now you see the load line marks now. Okay. You
Yes, sir.
know the vertical distance between S and W. How much is that?
1 by 48. So,
Of 1 by 48 of
of,
summer load draft.
yeah,
1 by 48 of summer load draft. And have we been provided with the summer load draft? Yes.
9.475. Yes, sir.
Yes, correct. So and right now the ship is floating with a draft of 9 meters. 9 meters is essentially less than this. So let me show you the water line here. This is the, let's say, water line at which the ship is floating right now at 9-meter draft. Okay.
Okay, sir.
Now the winter allowance will be the vertical distance between top edge of S and top edge of W mark. That would be 1 by 48 of summer load draft. The summer load draft 9.4755. If I divide with 48, what I'm going to get is the vertical distance between S and W. That would
Okay,
be
sir.
called as winter allowance. Clear?
Yes, sir.
Okay, why it is required for us to determine this? Because ship is moving in winter zone and we are supposed to load our ship in such a manner so that it does not object the loading criteria as per the winter zone. The
Okay.
ship must not be immersed beyond W
Beyond the
mark.
window. Yes, sir.
Yes. Okay. If it is floating in sea water and if it is floating in dock water, then some additional allowance may be given. Okay.
Freshwater. Ah, yeah, yes, sir.
Yes. But
Dock
but
water
for
means it
your
will be freshwater, or
yeah.
we will be like dock water, we will be considering as freshwater or seawater only.
Dock water is a water having density in between fresh water and seawater. That means the
Seawater. Okay,
density
sir.
which varies between 1 and 1.025 is called as dock
1.025.
water density. Right now, 1.013 is lying between these two values. So this is dock
Yeah,
water
so
density.
dock water. Yes,
So
sir.
initially the
Understood.
ship is in dock water and finally the ship is in seawater.
Seawater.
Clear? Yes.
Yes, sir.
It is required that ship must not float beyond W mark when it reaches here. When it reaches here in the winter zone.
Yes, sir.
Clear? Yes.
Yes, sir.
So far we have determined the winter allowance. Now the winter draft, the maximum permissible draft in winter zone will be the summer load draft and minus this value.
Yes, sir.
Okay. Yes. That means 9.475 minus the winter allowance. Okay. So 9.2776 meters is the winter draft, the maximum permissible draft in winter zone while being in seawater.
Seawater.
Okay. Now
Yes, sir.
next, the ship is right now floating in dock water. And when it will be moving to seawater, can we understand that the ship is going to rise by a certain amount because it is moving in a higher density?
Yeah. Yes, yes, yes. Draft will be reduced.
Okay. The ship is
Yes.
right now in a lesser density. And when it will be moving here, it will
Going,
be in
reducing the
higher
draft.
density. So it will naturally come out by certain amount.
Yes, sir.
Okay. Yes. That essentially mean that right now, dock water allowance needs to be determined. Dock water allowance is the change in mean draft when a ship moves from dock water to seawater and vice versa.
Okay, sir.
Yeah, it has got a formula, very basic formula. It is the difference of density between these two waters divided by 0.025 and into freshwater allowance. If you don't know this formula, you just remember it from now onwards. Okay.
Sure,
The
sir.
difference of both of the densities. Okay. That means 1.025 minus 1.013. Okay. And divided by 0.025 into freshwater allowance. This will give us the change in mean draft when ship moves from dock water to seawater and vice versa. Clear up to here?
Understood, sir.
Okay. So right now ship is in dock water and when it will be moving in sea water, can we understand that draft will get decreased by this much amount? Yes.
Yes. Yes, yes.
Okay. It will naturally decrease by this much amount.
Decrease.
Okay. Yeah. So now right now ship is in dock water. Right now the ship is here. Okay. Floating at a
Yes, sir.
draft of 9 meters. Floating at a draft of 9 meters. So
9
how
meters.
much should be the final permissible draft right now? That's what we are interested in. Okay. So that would be the winter draft. Winter draft is the draft up to here in winter zone. Okay.
Yes, sir.
Plus dock water allowance because here we have sea water, but here right now what we have is dock water.
Yes, sir.
We are aware of the fact that ship is anyhow going to encounter a decrease in its draft because of the density difference. So here an additional dock water allowance can be allowed. And
Yes, sir.
plus change in draft because of the consumption of a fuel. Consumption of the masses on board. Okay, this is going to be a decrease in the draft on the voyage. This is also going to be a decrease in the draft. So what we can do right now, we can increase by the same amount.
Yes, sir.
Okay, beyond this draft, let us not float with this draft while being here. Okay,
Yeah.
this is required here in the winter zone. So right now we can load the ship a little more with this much amount and with this much amount. Clear?
Yes, sir. Yes,
That
sir.
means winter draft plus dock water allowance and plus change in
Plus
draft due
change
to
in the
consumption.
consumption.
So that's what we have got the final permissible draft.
Okay.
Okay, so let me now take you on the subsequent part of this problem. Okay, question is asking in part B, calculate the amount of cargo which the vessel can load.
Load.
Okay. Yeah. Right now, what is the draft?
Like final draft, it will be
Right
9.52.
no. Right
Right
now,
now,
how much is the
9
meters? And how much is the permissible draft which we have determined in dock water only?
9.52.
Yes. That means right now, if we keep the draft this much, when the ship will
Yeah.
move in winter zone and in sea water, it will naturally be floating on this draft.
Yes, sir.
And it will not be objecting the criteria.
Criteria.
Clear? Yes.
Yes, sir.
There will be a reduction of this much amount and there will also be a reduction of this much amount.
Yes.
Understood? Okay.
Yes,
So
understood.
now the final permissible draft is 9.52504 and the present draft is 9 meters. The difference amongst both will give us the
50.
sinkage allowed right now.
Okay.
Right now
TPC,
floating
yeah.
at 9 meters, but this much is the maximum draft at which we can make it float. So
Yes,
how
sir.
much sinkage we can allow? We can allow this much sinkage. And the
52 point
sinkage multiplied by TPC will give us the amount of cargo or amount of mass which can be placed
mass.
onto the ship.
Yeah.
Clear? And right now
Understood.
here is a twist. We will assume as if the TPC is constant. TPC is constant as if it is 30 ton only. In
Okay.
reality, we are supposed to take TPC for dock water here because we are loading in dock water.
Okay.
But it is our assumption that TPC is constant for the present case and for the final case. That means TPC is constant on the whole voyage, 30 ton. So you
Okay.
will have to mention it in a statement, assuming TPC as constant on the voyage. So sinkage into TPC will give us the amount of cargo which is to be placed onto the ship.
Okay, sir.
Clear? So 1575.12 ton can be loaded onto the ship.